Okay, so I think I'm actually going to zoom in on it a little bit while we're filming. It might ruin the shot a little, but what'd you find out here?
Well, we got a rhombic dodecahedron. Those are kind of dual.
Okay, so you're not convinced this is the dual.
Well,
What's bothering you about it?
it seems like we couldn't actually get the true dual as by connecting the points in the center. These are all a little outside of the shape.
Talk a little louder. So, okay, so you're worried that they're outside of the shape. Okay, so what do you think?
Yeah, that's kind of the problem I'm seeing too. Although, the dual would be smaller if they were truly on the same face, but you can kind of see that with a rhombic dodecahedron, when you find the centers of their faces, it's the same size.
Huh.
It just keeps going back and forth. From the rhombic dodecahedron to the cuboctahedrons. I think it's fine.
Okay, so when you say you think it's fine, what do you mean?
So I think this is the dual of the shape, but it's not to size.
Okay.
So
I got the idea for this project from a paper I saw by Alex Kontorovich and Kai Nakamura. It was published on Twitter. So show that picture. And okay, now that you've shown it to the camera, look at the picture and tell me what you see there.
Well, I see a cube. I definitely see like a cuboctahedron, and then I see the rhombic dodecahedron too.
Okay.
So that it probably means they're duals because we've got basically the same thing here.
Okay.
And you can also go back and forth too.
All right, show it to your brother. So what do you see here?
well, it's got these circles kind of around. Where is it? It's around each of the faces where the rhombic dodecahedron crosses the edges of the cuboctahedron. Kind of has circles, and
Right.
also it might just be a trick of the circle, but you kind of have these arcs going kind of around here.
Okay. Do you think there are the intersection points on the squares and the triangles actually form circles?
Probably because you could just these should be all the same distance away from the point actually on the face right here.
Okay, why should those be the same distance away?
Because we've got a square, and we're intersecting at the same point on the square.
What do you?
Also, theoretically we have the center of this square. So
If you just project down to the face, it's
Okay.
the center.
Cool. So, and what do you mean you're intersecting at the same point of the square?
So the rhombic dodecahedron always crosses this edge at the midpoint.
Okay. Interesting. Is there anything else you could tell me about the rhombic dodecahedron that you've made here and its relationship to the cuboctahedron?
Well, it looks like they have similar. They probably have similar volumes, just because how the dual is actually made here.
Yeah, actually finding the volume of a rhombic dodecahedron is an interesting exercise all by itself. Anything else you notice about the shape?
Well, I just think it's interesting that in the fourth dimension, the equivalent of this shape in the fourth dimension is a platonic solid,
Okay.
but this shape isn't.
That's,
Its dual is not a platonic solid, but it the original is, which is something we don't see with our normal platonic solids.
Yeah, so maybe it's interesting to ask the question in the fourth dimension, what's the dual of the fourth dimensional rhombic dodecahedron? All right, we'll stand it up on maybe one of the yellow corners, and we'll spin it around. And hopefully that'll give a nice view of the shape. Yeah, it's neat. It's neat that we were able to make this out of Zoom. I was hoping that would be the case, and so now it is.
nice.
All right, good work this morning, guys.